Welcome, guys. This is the AP Environmental Science Chapter 13 lecture over renewable energy sources. So I'm going to run quickly through this lecture. You guys know most of this material anyway. I'm just going to try and fill in the blanks and hopefully make this as quick and painless as possible. So the central case of the case study for this chapter is all about wind power. We do have a lot of potential to use wind power here in the U.S., but as we've seen, there's definitely some opposition. Advantages are that wind power is inexhaustible. It's definitely renewable and never going to run out of wind. We could create enough electricity to supply or power the lower 48 states. Currently, Texas and California are the top producers, but like we've talked about, we need to produce energy locally to get true gains from renewable energy sources. The bottom point there, we know a lot about renewable energy options here in Montgomery County. We actually have a decent amount of renewable energy. So this is just a basic summary of how a wind turbine works. You guys are living this right now. We've got blades that cause the fan to turn. We've got a gearbox that is really important because sometimes we need to turn it off if the wind is blowing too fast. Will burn up our generator. So we turn the turbine, which causes the generator to generate electricity, which then we run a power cable down to a battery or to the electrical grid or something along those lines. So why is energy efficiency important in energy resources? Well, because you got to spend money to make money. You got to spend energy to make energy. If we can be more efficient with our energy and how we use our energy, then it's not as big a deal that we transition as quickly to renewable energies. Or if I said that a different way, since it's going to take us a long time to transition to renewable energy sources, a good step in the right direction is to reduce our energy usage and to be more efficient. Maybe that involves increasing the efficiency of appliances, like buying Energy Star appliances or buying hybrid vehicles or using green building design, or any number of industrial operations. But we just need to be more efficient in how we're using electricity specifically. So how do we use it inefficiently? First of all, we need to look at the definition of efficiency, and that's how much work we get from each unit of energy. So I always go back to that. You got to spend money to make money. If you spend $100 on an investment and you make $101, at least you've profited. If you spend $100 and you make $50, you've lost money. So you've been inefficient with your investment. If you invest $100 and you make $1 million, that's been a really efficient investment. So our energy efficiency is just how much work we get from each unit of energy. So some advantages to reducing energy waste. It's the cheapest way to provide more energy, reduces pollution and degradation, slows atmospheric warming, all those types of things that we've been talking about all year long. Definitely all unit long. Daily activities waste energy, like working in buildings with poor heating and cooling. We saw that in our school energy audit. Driving to work by yourself. I could help the environment if I rode with someone else. If maybe OP and I live in the same town, if we carpooled every day, then we would save one trip back and forth to school. Also driving vehicles that use gas inefficiently. Not only does it cost more money to fill up the tank, but you're also burning more carbon. You're being less efficient with your energy. There are 4 widely used devices that waste energy: are cars, industrial motors, and incandescent light bulbs. That's excuse me, some of the old school light bulbs. Those waste so much energy because we use so many of them. It's rare for for a light fixture to have one incandescent bulb. Typically, they have 5 or 6, and you might have 5 or 6 of those in your home. So you may have 30 light bulbs in your home to power 5 light fixtures. So how can we improve energy efficiency? Cogeneration is something that I think we briefly talked about, and that's the idea that we're going to combine heat and power. So I'm in the process of buying and installing a wood stove in my home. So I'm going to be using biomass to heat my home while I'm creating heat. If I'm creating heat, I could also turn a turbine that could generate electricity to power the lights and everything else in my home. That's the idea behind cogeneration. So we're producing two forms of energy from the same fuel source, which is definitely going to improve efficiency because you're getting more bang for your buck. Replace energy wasting electric motors, so Energy Star appliances, things like that. Replace our old appliances. Recycle materials, of course, e-waste we need to recycle and things like that. Switch from low efficiency incandescent lighting to higher efficiency LED lighting, improving our light bulbs and all of those types of things. Moving beyond what we can do as individuals, if we set up a smarter electrical grid, we can have a wider ranging impact. It's not dependent upon each individual user to reduce their impact. We're kind of reducing it for them. When we talk about a smart grid, we're talking about ultra high voltage, which helps us transmit things really efficiently. We need to redesign our transmission lines. You guys may be too young to remember this, but maybe not. But there was a big breakthrough in internet speed when we got faster lines, when we got lines that could carry signal faster. Well, that's what we're talking about here, same kind of idea. If we can replace our transmission lines, our electrical wires, with newer high efficiency lines, we can we waste less energy. We lose less energy to friction and things like that. They're digitally controlled, which lets us respond to local changes in demand and supply. We can reduce the amount of supply that we give to people, that we allow to people during the day, which sort of cuts down on waste. Maybe we limit the amount of electricity folks can use, so rather than leaving their TV on all day and controlling the temperature in their house, maybe they don't have the electricity capacity to leave their TV on all day. They have to find some other way to scare off would-be thieves and things like that. And then it's easier to buy renewable energy because a smart grid is set up that way. It's set up so that renewable energy can feed into it really, really efficiently. Other ways that we can improve efficiency in transportation are those hidden prices in gasoline. I talked about the fact that biofuels could be competitive if gasoline was $7 a gallon. Well, if we didn't have some of the subsidies that we give to oil companies, if we didn't have some of the taxes, or if we did have some of the taxes that we should have in terms of cleaning up the aftermath of the use of gasoline, then gas would be about $12 a gallon. So if we didn't have those hidden implicit costs, biofuels would be cost effective. So think about that when we talk about energy subsidies and things along those lines. We should be subsidizing our ideals. We shouldn't be subsidizing our history. We should be making it affordable to be better, not making it affordable to keep things the way that they are. You see, we have special interest groups that lobby to prevent laws that raise fuel taxes. We definitely could expand mass transit and high-speed rail. We've looked at that a decent amount. We could use solar roadways, something along those lines. We could completely change our infrastructure, encourage biking, things like that, walking to work, carpooling. All of those types of things are better ways to manage our energy in terms of transportation. So the next step, and the one that you're probably most familiar with, is the improvements on to vehicles. So some examples of those are super efficient cars, ultra light cars that are made of materials that are extra light. Certainly the passenger cars of today are way lighter than they were in the 70s and 80s. We use a lot more plastic where metal was used in the past, and we used aluminum where steel was used in the past, and things like that. So the lighter the car, the less energy it takes to propel that car down the road. Hybrid cars we've talked about. Plug-in hybrid cars we've talked a little bit about. There's energy-efficient diesel vehicles that are out there. There are vehicles that run on biodiesel. We'll talk more about that in a little bit. Electric vehicles with hydrogen fuel cells exist, and those are really cool. Basically, the pollution from a hydrogen fuel cell is water. And if the fuel cell is set up correctly, the water can be split and then recombined, and it almost makes a perfect, perfectly efficient engine. Almost. Of course, nothing is perfect, but there's a lot of potential there for the future, but we're not quite there yet. Something else to think about is we talked about how increasing mass transit could help. If we increase mass transit and we make those mass transit mechanisms more efficient, now we're really helping ourselves on two fronts. Our buses are now being powered by a biodiesel or by a hydrogen fuel cell. So we've got more people being carried around per mile, and we're using a more efficient energy source per mile as well. We can design buildings so that they save money. We can do green building design. We can use green roofs, especially with soil and vegetation. We can use that super insulation that kind of eliminates the need for a heating system. That wouldn't work in an ecosystem like we have here in central Indiana, but in some more, not tropical regions, but warmer climates, that would work. Someplace like Tennessee or Georgia, maybe that would be more effective. And then check out that LEED. It's the U.S. Building Council on essentially building green buildings. That's a really cool group that's doing a lot of really, really promising things. I want to talk a little bit about green roofs. So think about maybe when you were a kid, your mom or your dad told you to make sure you wore a hat when you went outside because most of the heat that you lose goes out your head. I'm talking about the winter time. Obviously, maybe you were going sledding or something like that. Make sure you wear your hat because you don't want to get sick. Well, the same is true of our buildings. Warm air rises always. It's not just from humans that warm air rises. So if we can super insulate the roof, we're going to save a ton of energy. Well, soil, dirt, and plants are really good at insulating. They do a great job of trapping heat. So putting a green roof benefits us in a lot of ways. It's going to really insulate the roof and keep the top insulated. We're not going to lose all that heat out the top of the building. But we're also theoretically producing produce, producing lots of stuff that could be used in that building. So if we did it in a school, we could eat that food in the cafeteria. We could work that as part of our environmental science curriculum, and it would reduce our heating costs. So it's kind of a win-win-win. So ways we can save money in existing buildings. Boy, this looks familiar. This is what we did with our school energy audit. So I can move quickly through that. Here are our very typical ways that we can save energy in the home. Make sure you check those out. I'm not going to spend a lot of time reading through all those, but you probably could make some small-scale changes in your home that would make a difference. I'll leave off there on the first part of the flip. 13.2 is all about sources of renewable energy, so I'll have that be its own self-contained video.